This is the start of a brand new series of videos where we're going to work through every single Pearson textbook for A-level maths and further maths and do every single challenge question that's found within them. Part one is just going to be focusing on book one because we have to start somewhere, chapter one. Now, as you may be able to guess, the chapter one from book one challenge questions are insultingly easy, but there's nothing I can do about that. If you know binomial theorem and you know your coefficients for 4 are 1, 4, 6, 4, 1, then this is even easier than that. Even if you don't, you of course just expand this out laboriously, where you maybe expand those two together to make x squared plus y squared plus 2xy a couple of times, and then you expand all of these out and do all the terms, and you get this, and then you tidy them all up, and you get the same thing. That's the first challenge question done. Number two then, this is actually an interesting question, although again, it's not too bad. Whenever you see a quadratic that's not really a quadratic like this, just make it a quadratic. So like replace this with a y squared and this with a y, and just think, well, what would that factorize to? And with a bit of trial and error, there are proper ways you could try and do this, but I just prefer using trial and error to find some stuff. I eventually found these. And of course, to get it back into this state, you've replaced y with x squared. So let's just put that back. So replace these y's with x squareds, and we get this factorization. But what's nice about this question is that this is a product of two things, but these are both difference of two squares. This one is obviously x plus 1, x minus 1. And now this one is a little bit harder to spot, but it's 2x plus 3, 2x minus 3. And now we end up with our four linear factors. So actually quite an interesting question, but regardless. A here is obviously trivial. Root a times root a is a, root b times root b is b, and then the cross terms cancel, so we get a minus b. And what that is trying to help you with is that if you take each one of these terms, like we'll start with the first one, and you rationalize it by timesing it by root 1 minus root 2 over root 1 minus root 2. You've just worked out that these two things on the bottom here multiply to make a minus b, which is 1 minus 2, which is minus 1. And of course, 1 times this is just this. But of course, when you divide by minus 1, you can just swap the sign. So this is root 2 minus root 1. And this is going to work for this one as well, right? Because the a and the b don't really matter, so it doesn't matter what they are. So when you rationalize this on the bottom, you're going to get minus 1. On the top, you're going to get minus root 2 plus root 3, but then you can flip it over, so it's root 3 minus root 2, right? So this one is just, and you can do it the long way around if you want to, but it's just going to be the same idea as this one here. So because the 2 was here and the 1 was there, it swaps over because there's minus 1. Going to be the same thing here, and you get root 3 minus root 2. And you can do that for all of them. So the next one is root 4 minus root 3, and so on. And that's quite nice, because when you do that for all of them, notice how this root 2 and this minus root 2 just cancel with each other. And likewise, this root 3 and this minus root 3. And that's going to happen all the way down the line, except for this minus root 1 and this root 25, because they, being the largest and the smallest numbers, have nothing to cancel with. They have no pair. So they're just going to be left over. Of course, that's 5, that's 1. 5 minus 1 is 4, and that's equal to the right-hand side, and we're done here.